Right, on the bench this evening is another impulse buy, bought over the Christmas period, and there was a bit of a long-winded saga trying to get hold of this parcel. The chap I bought it off and listed it for sort of like £4 postage and packing, so I won the item, paid by postage and packing. He said, "When do you want to pick it up?" I said, "Well, I don't. I want it posted. That's why I paid for the postage and packing." And it all went very quiet, and so I sent him a message and said, "Look, if you're not going to post it," I said, "refund me." I said, "But you listed it as postage. I paid for the postage. You know, in your description it says pick up preferred, but we'll post." So, you know, so and then it all went quiet again. I was thinking, gave it about a week. I wasn't in much of a rush for it after Christmas, and I sent a message again saying, "Look, give me a refund then if you're not going to send it." And he said, I'm just weighing it up now. Unfortunately, the weight of the item is more than I thought, and it's going to cost £10 for postage." And I said, "Well, okay, if you're going to post it, send it to me though." I said, "We've been messing around long enough." He was very decent, and I didn't lose my temper. I was quite. I think he was a new seller, and he hadn't really got much experience with Facebook, eBay, and he was just hadn't. He listed it as a collection preferable, but he needed to be a bit more specific than that. It should have been cash on collection only, but he hadn't listed that. Anyway, long story short, he basically I paid the extra money for the postage, and he sent it out, and it finally turned up. And it weighs about, I suppose it weighs about 3.5 to 4 kilos. So yeah, this is my latest acquisition. I've worked on one of these before, and you'll see why in a minute. It's not really an unboxing video. As I said before, I find unboxing videos boring, but I thought it might be a bit more interesting to show you it being revealed. I tend to do that normally, as you know, in my videos. I'd like to get it on the bench and see what we've got. It's fairly well packed. I wouldn't say it was double wrapped, so I've got the little letter in there. Probably just a return address if you want to send it back. Yes, it is. So let's have a look inside, see what we've got. Packed with polystyrene, which is always a bit of a pain, because polystyrene, they won't take it away with the recycling, so I'll have to take that to work and get rid of that. This is the polystyrene box, which is quite nice. And it's definitely, I must admit, it's pretty well wrapped actually. I'm not worried with the wrapping. Any ideas what that is? Be a little bit careful when I cut this open, I don't scratch the top of it. Don't even supply a bloody plug with it. There we go. Let me just set the exposure a bit better so you can see. I have a foot missing. So let me just see if I can set the exposure a bit better for you so you can see a bit clearer. Wrong way. So this is a Roband digital voltmeter. Now, I don't know if most people probably know that I do work for Roband. And it was founded by its chairman, Bernard Gold back in 1956, and they started making small power supplies for military, basically, and then they went on to other commercial stuff, and this is one of their power supplies. Well, this is one of the voltmeters they made, and they made a couple of voltmeters, but this is one of the early ones. This is a Nixie tube voltmeter. On the back, we can see here we've got the Earth tested July 82. Obviously, that's a later stamp. That's one of our Roband stamps on the back that we still actually occasionally use those on some of the older equipment. So this is, yeah, a Nixie tube multimeter. And basically all we get to do this evening is just power it up to see if it actually works, and see if it's viable. Now the chap told me it wasn't working, and that was sort of really why I was sort of interested in buying it. We have actually got one of these in our collection at work, so usually if I find something like that on eBay for that's made by Roband, I will take it to work. But this one here is obviously we've already got one, so I want to keep it because it's Nixie tube and because it's a Roband meter. So this is the Roband 1500, and on the front panel here we've got the 1K kilovolt section, 150 volts, 15 volts, and 1.5 volts. As I say, Nixie tube display, two front terminals on the front here. So the first thing I think I'll do is probably plug it into and chuck a safe block on here and plug it into the dim bulb and put a 60-watt bulb in series. Now from memory there's no capacitors across the input on this, so you're probably fairly safe, and the transformer no doubt is going to be very over-spec'd on this anyway, so it should be fine. So let me sort out some connections to the unit. We'll connect it up through maybe a 30-watt dim bulb. We'll power it up and let's see if we get anything. Right, we'll connect it up to the 46-watt dim bulb. I think that's probably the sort of ballpark you want. Gives us a bit of protection. There is a short on the input, or I've got the input voltage set wrong, which I'm pretty sure I haven't. I think it's only a 240-volt input, to be honest with you. So let's switch it on and see what it does. Well, it says 1.5 volts. Okay, so that's clearly wrong, but the display is working nicely. So let me just prop it up so you can see. And the dim bulb's obviously not lighting up at all. And the voltage is coming down, so it looks like a cap reform. Let's try it on a different range. There we go. The display is nice and sharp. I'll give you a zoom in a bit so you can see. That's off, 1 kV. Oh, gone off again. Okay, so it's got us. You can see the way when I switch it on, it flickers and then goes off again. So it looks like a dodgy. That to me looks like possibly a dodgy switch. Okay, so what I'll do is I'll turn it, leave it on. I'll shut the power off and recycle the power from here. Okay, no, so I wouldn't be surprised if that all that is a dodgy switch. It's not because the dim bulb's in series with it, because the dim bulb's actually not illuminated, so that's not causing any drop at all. So I think the next thing to do is, clearly the display works and there's clearly signs of life. I'm going to take the front panel off and have a look inside and see what we can find. Okay, the inside is revealed. Unfortunately, I couldn't find any information. We used to have a load of old microfiches on these power supplies, but I can't find any information on them. But believe it or not, we've still got these capacitors in stores. So this is the power switch here, which I suspect could be the problem. I'm going to run some contact cleaner through it. So power supply section here, and this is obviously the driver boards for the displays, just here and here. And up at the top is probably the analog to digital conversion, maybe. See a couple of neons down the back here, which are obviously for over limit lights and things like that. Really not sure. We don't work on these meters anymore. You know, it's not the sort of stuff that gets sent back from a customer. We do get in queries about circuit diagrams and things, and unfortunately we have to let people down because we haven't found any information on these at all. So what I will do is, first of all, we're going to run some contact cleaner through it, or I'm going to just use WD-40 just to see if that improves anything, and see if that gives us a reliable switch on. So the power switch is clearly here, so we just give it a bit of. That's the main switch for the power at the back. Let me zoom in a bit so you can see. So that's that are working. Now there's the main selection switches are these ones at the front, which is just a standard wafer switch. So let's power it up again, see if we've got anything now. Yeah, there we go. That's all it was that was the switch problem there. So clearly it's got a nice bright display, a nice classic Nixie tube for all you sort of like vintage Nixie tube lovers. I'll give you a bit of a closer up on that so you can see and get your rocks off on it. As I say, nice bright display. You see that the offset appears to have gone now. It's probably a capacitor reforming. What we will do is we'll run it for a while and we'll have a look at the supply ripple just to make sure it's not too bad. But what I would like to try now is just apply some voltage to it and see how far or how accurate it is. You might be surprised, it might be very accurate. So what we'll do is we'll connect up an external power supply, try to find somewhere where I can prop it up so you can actually see. You know, that's better, isn't it? You can see now. So I'm going to connect up. Seems quite apt to connect it up to a Roband power supply, I suppose. So I'm going to connect it up to one of my Varexes. I'm going to connect it up to my 3010. I haven't confirmed the output on it, but that should be around 10 volts. So we'll connect it up to our front panel. And that says 10.23 volts, okay, which I think is overreading slightly. Let's get that out of the way. I don't want that in the view of the camera. So 10.22 volts. So what we'll do is we'll get our fluke multimeter and just connect that to the front panel and just see what we're actually putting into the unit. But it certainly looks like it's within the ballpark. It's probably never been calibrated, this meter, and I'm not sure of the original accuracy of these meters anyway, but it's probably sort of 0.5%, something like that. So let's just have a look, see what we're putting in with my fluke. Let's just hook this up. Okay, I'm putting in 9.98 volts and it's showing 10.22. Now these are fairly straightforward to correct. So what I'm going to do is I'm going to make an adjustment on the control and get the thing to stay on this so I can measure it properly. Okay, so the adjustments on the front side panel here. So we're on the 15 volt range. Are we on the 15 volt range? Yeah, we are on the 15 volt range, so that's the adjustment here. So we could adjust that fairly straightforward. What I will do is check it on the 15 volt range as well, and the 150 volt range. So let's put it up to about 30 volts, 29 point. So my fluke is now reading exactly 30 point. Okay, it's 30 volts, 30.03, and the Roband meter is reading. You can't see there, can you? It's reading 30.8. So it is out of spec. So let's have a look. I'm going to have a look inside, see what the adjustments are, and see if we can bring this in a bit closer into spec. Okay, you see this annotation here for set 12 volts. Right at the back behind that switch there's a pot. You can see that just under that yellow looped wire there's an adjustment pot. Now it says set 12 volts, but I'm not entirely sure where you're measuring the 12 volt output. So I'm going to have a probe around, see if I can find out where this. Obviously this is the reference for the 12 volts. This obviously it's 12 volt reference that it relies on to make the measurement. Try and find out where the 12 volt comes from, and we can see if we can adjust that up. It also looks possibly like there's been, oh no, it's an encapsulated piece of equipment in there, but something has been encapsulated in sort of clear silicone. I thought it was a capacitor leaking, but no, it's actually an encapsulated item. So Let's see if we can find out where this 12 volt comes from and adjust that up, and then we'll make a measurement again, because both the rails are out. It would suggest to me that there's probably a reference that's out of alignment. Okay, I found the adjustment. So the pot's, as I say, underneath this yellow wire here, and it's that fourth pin at the bottom of the board. I don't know if you can see that underneath that blue capacitor. So we set that, I checked that, and that is exactly on 12 volts, so the reference hasn't moved. So it's going to be a case of simple of adjustment, these controls here, and trying to get these rails a bit better in spec, so they're the input's a bit better in spec, so it reads the correct input when we put it into the front panel. Right, let's start with the 10 volt range, the 15 volt range, and just see if we can bring this in. So I'm putting exactly 10 volts into the unit, and it's just this adjustment on the side here. I have to do it on the side, it makes it easier. Let's see if we can bring this in. Now, interestingly enough, I can't get that in spec. I can't pull that in. Now, the only other thing it can be, because it's wrong on all the ranges, I'm wondering if the input reference is wrong. So what I'm going to do is I'm going to drop it back to say about a volt, and check the low range, because that won't be going through any attenuators and things like that. So let's go to just adjusting the voltage now. So that's 580 millivolts. Yep, that's high as well. So what I will try and do is tweak that set 12 volts. It might be the reference. Now, I'm not sure if that's right or not. As I say, we haven't got any manuals. No one at work will know this meter. Everyone who worked on this meter has either died or retired. So I'm going to try and adjust the 12 volt reference. I imagine 12 volt reference. It's making a slight adjustment, but it's still not going to bring us into 580. No, we're not going to get that into adjustment. So we need to start looking a bit further into this thing. It's not going to be a simple case of adjusting that input. Not too sure what else to do. The only thing I can probably do is go through the archives at work and see if I can find any setup data on one of these. But it's going to be a long shot. But it's clearly that the ranges are wrong on whatever range I select. It's out by the same sort of percentage. So that would suggest there's a reference voltage is incorrect or something like that. Yeah, so for the time being, I'm going to pause, have a look, fiddle about inside, see if we can get anything working, and we'll come back. Well, unfortunately, I've been through the archives at work today, and there's a lot of stuff we don't throw out. We like to try and keep all the sort of drawings and things like that from all our old products. And I went up to the drawing office today and asked the chap who'd been there for quite a while. I said, you know, I'm looking for schematics and setup data for the Roband 1500. And bear in mind, he's been there 20 years now. And he said, what's a Roband 1500? I said, it's the digital voltmeter from the 60s. He said, no, don't know that unit. I said, well, I'm sure I've seen some information on this meter. He said, well, go and have a look through the paperwork so you can find anything. So I had to rummage through all the paperwork, and there's lots of different variants of the Roband power supply that we've made over the years. And I searched through and I couldn't find anything. And I came across a drawer with some microfiche stuff in it. For those who don't know what microfiche are, they're like a very small transparency that you put onto a projector and you project it onto a screen. So basically you can store a lot of information in a very small area. And I came across the Roband 1500, and sure enough, we had all the parts lists and everything, but nothing about setup or calibration or anything like that. So I went to see one of our longest employees there, he's been working there nearly 50 years, and I said, do you know anything about the Roband 1500? And likewise he said, what's the Roband 1500? I said, well, it's the multimeter we made back in the 60s with Nixie tubes. He said, oh yeah, he said, that wasn't my department. He said that was actually undertaken by another chap, Nigel Soanes. And Nigel Soanes is, funny enough, the chap who passed away, a friend of mine who passed away, who's actually got this higher booster that I'm looking at the moment. and he said he used to do some work on those. He would have been the person to ask. And I said, oh, that's ironic, isn't it? You know, you get this meter and it's not working. Anyway, so we sort of had another quick flick through the drawing office, couldn't find anything. So we sort of come to a dead end on this voltmeter. But what I have done is I've sort of had a quick look round it and sort of taken this side cover off here, and this looks like this, sort of like the high sensitivity front end. We've got 4 pots on here. This pot, I've no idea what it does. Basically, I photographed the board before I adjusted any of the pots so we can see where the pots were originally. And I messed about with these 3 pots here, and I've actually got the scale calibration far better than it was. It's not perfect, but it's I think it's probably worthy in spec for the meter. Unfortunately, I don't even know what the specs of the meter are. So I'm just going to quickly run through it, let you see. Now, at the moment, we're only using a low voltage setting because basically, it looks like you set all your low voltage ranges on the on this board here, and then the multiplier is done with the range switch here, and that's done with the pots on the side of the unit there. So that's fairly straightforward. All I'm interested in is the low input range, which is a maximum of 1.5 volts. So what we're using here is we're using my process calibrator, and of course you won't be able to see it because it's in the light. But anyway, we're going to you have to take my word for this. So we're actually feeding in at the moment. We're feeding in 100 millivolts into the Roband 1500, and you can see it's just shy of 100 millivolts there. So we'll go to 500 millivolts. Oh, no, we won't. We'll clear that. 0.5, enter. That's 500 millivolts. 0.49. Okay, I can actually bring that up a bit higher, but it's sort of between the high limit and the low limit. You're trying to get it in spec. If I go too high here, it'll be miles out at the top end. Let's try 1 volt. That's 1 volt. Pretty good. 0.99. Let's try 1.2 volts. 1.2. Enter. 0.119. Pretty good. Let's go down. Let's go to top range. So 1.5 volts. 1.49. So slightly below what it should be. Pretty good. Let's go to. Let's see. 50 millivolts. 0.05. 50 millivolts. Is it entered? No. 0.05. Enter. That's it. And that's a bit low, okay, but this is on the limit of what this sort of meter would be able to respond to anyway. 0.1 again. That's not 0.1, that's 0.1 millivolts, sorry. 0.1 volt. 0.1. Enter. Yeah, it's 100 millivolts. So it's pretty good, isn't it? You know, it's certainly not a mile out. I don't know what the spec, as I say, I don't know what the spec of the unit is. I can adjust that up a bit to bring that back up. Let's try to get that up. There we go. We just want out the transition again. 0.9, 0.1. There we go. So let's go 0.5. Bugger, done it again. Enter. 0.5 millivolts. Bear with me. Volts. 0.5. Enter. Pretty good. 1 volt. It seems to be getting better actually as I use it, and I haven't done any recapping on it. I'm not going to bother recapping this thing. I'm not that bothered with it. So let's try 0.998 millivolts. Pretty good, isn't it? I'm quite happy with this actually. And last check. Let's go 1.123. 1.12. So I'm very pleased with it actually. It's actually sort of seems to be getting better as the more you use it. So this is the really the main reason why I bought it is because it's a Roband piece of gear, but also because it's got Nixie tubes in it. I love Nixie tubes. I think they're great. I think as most people do. It seems to be working pretty well. It's in lovely condition. Paid very little money for it, and I thought it would be quite an interesting project. Anyway, thanks for watching. The Hayabusa will be coming in February sometime, hopefully. Once I've got the cash together. I've just had to spend £1,000 on my car, which has peed me off rather. Yeah, once I get the money together, I get the Hayabusa here, and then it's going to be a case of stripping the fuel tank down, cleaning the carburetors, cleaning the fuel injection lines through, and basically getting it to run. Anyway, thanks for watching, and more to come. I just run this through on the higher voltage settings. We've obviously done the low voltage range. Let's see if the high voltage attenuator is set correctly. Now that's adjusted through this jack post in the side here. There's a couple of pots here. You see the trimmers in the control at the moment. I've gone through and adjusted it the best I can. It was a bit of fiddle because obviously I haven't got service manual and things. I've got it pretty accurate actually. So we're actually on the 15 volt range here. We're going to apply some voltage to it from our Keithley, which we know is pretty accurate and perfectly good enough source for this DVM. So let's go to 10 volts. Oh, no, 13 volts. We've got 13 volts programmed. 13 volts. Let's go 15 volts. 14.99. Excellent. Let's go down to 5 volts. 4.99, that's good. Okay, so we change the range to 150 volt range. So we'll go to let's go to 50 volts. 50 volts. That's good. 100 volts. Perfect. Let's go 150 volts. Let's do this another way. 150. That's the top of the limit of the range of this meter on this scale. So we'll go to the 1 kV range. So it should be 150 volts. Brilliant. 150 volts. 250. 350. 450. 550. 650. 675. 775. Oh, slightly out there. Bear in mind, I mean, we're within very tight tolerances now. 875. 975. Alright, let's push its limit. 1076 volts. 1100. Okay, I'm not going to call it there. So it looks to me, it's just one other check we can try actually. We'll reverse the polarity. So we're going to go to negative 205, which should bring this annotation up. Okay, so we've got a DC balance, slight DC balance error there. That's interesting. So that's another pot that needs adjusting somewhere. So I'm going to have a quick look inside to see if I can work out which one that is. But there's obviously an offset control somewhere. I'm not sure which one it is. It could possibly be the one at the bottom in the corner that I couldn't work out what it was doing. So, but it's clearly pretty accurate in this, as long as you don't reverse the polarity. Let me just try the lower ranges and see what that does. So we'll go to so this is 5 volts. Reverse 5 volts. Yeah. So we've got an imbalance here. And initially I thought, you know, if the imbalance would show up with a sort of like a negative figure here, but it doesn't. It's obviously only affects if you actually put a voltage into it. So minus 1 volt, plus 1 volt. So clearly we've got an offset there. So what we're going to do is we're going to go to the one, I think, obviously bear in mind I'm doing this by eye. I'm going to go to 1.4 volts and adjust the 1.4 volt setting there, 1.43, 1.39. So I'm going to take this cover off again, have a twiddle around in here so we can get that balance correct, and then we'll have another go. Let's do a comparison then. Calibration is about the best I'm going to get it. It's a bit of a compromise. So I say, can't find any information at work about this setup, circuit diagram and everything. It's obviously long lost data. That's I think someone said they were made in the early 70s, and they were someone who started there in 78 said that they were already redundant. They were already stopped making them when he joined. So it's an old meter. I don't think we sold a huge amount of them. So all right, let's run it quickly through the calibration or comparison between the Fluke. We know this Fluke's very accurate. So we're feeding in from the Keithley 240A high voltage power supply. This is a 1 volt feed, minus 1.000 according to the Fluke. We've got 1.014. There's a bit of uncertainty of how accurate it is at this sort of range, but I'm pretty sure it's pretty good. I'm quite happy with that. That's okay. And we go the positive range, and there's a very slight offset probably on the input of the amplifier, but yeah, pretty good there. Let's go to 1. Well, we can't really go any higher. Let's try a variable level of something like 1.4 or something like that. So I need to adjust that to how this controls. So this is put in 1.378 according to the Fluke, and it's showing a 339 on the Roband power supply, the Roband voltmeter. Let's try it on the 15 volt range. So let's give it as 11 volts. Now that's a calibration error, and I can bring that easily in on the Roband meter, because there's a adjustment on the side which is just the multiplier. So we know what you do is you start with the base voltages, which is the low end range, get that accurate, get the balance right, and then as you work up the ranges you adjust the pots on the attenuator. Okay, so we're a little bit out there. It should be 11 volts. We've got 11.13, but the offset should be good. Yeah, that's pretty good. Okay, so we'll go to 150 volts and just see if that's what that's like. So that's 111 volts, and you see we've got 112.2. As I say again, that's an adjustment on the attenuator, so I can bring that in. So I think I'll have to do that. I haven't adjusted that attenuator yet, and then we'll try the 1 kV range, and we'll put in, let's put 500, that should be 511 volts. Okay, and you can see here now it's quite a significant amount out. The Fluke showing 510 volts, and the Roband showing 518. So let me just get in there with my screwdriver and have a twiddle about. We'll come back and we'll run it through again and see if it's any better. I'll run through this one more time. I found when I was adjusting the attenuators, there's another pot in there that says set 12 volts, and it looks like the reference for the meter. And that's allowed me to pull everything in. I've got some really good results now. Very pleased with that. So here we go. We're feeding in 1 volt. You see on the Fluke it's 1 volt. It's 1 volt on the Roband meter. Minus 1.01, minus 1.02. Very pleased with that. That's excellent. I mean, probably because I've adjusted the reference slightly. There's an adjustment inside the cage inside of the meter that can adjust the offset slightly, but that's perfectly adequate. I mean, that's well within spec, I should think. I'm not even sure what the spec of this unit is. Okay, so that's at 1 volt on the 1.5 volt range. We'll go to the 15 volt range, and we'll go halfway through the range. So let's do 7.5. Let's do 7.5 volts. Yeah, let's do 7.5 volts halfway through the range. Just turn this down to 7.5 as close as I can get it. Okay, 7.49, 7.50, and you see pretty good correlation between the two. Very pleased with that. Negative, spot on. Okay, let's try it in the 150 volt range. So we'll go 75 volts for that one. 75. That's not 75. That's 75 volts. So we've got 74.9 on the Fluke. Got 74.9 on the Roband. Minus 75, minus 75. That's excellent. It's really much better results than I was getting. I tried everything on the actual input attenuator and the amplifiers, and I couldn't get that to balance. But now I've adjusted that reference up slightly. I've managed to pull it all in. See, the references have drifted or slightly, something altered it over time. So 1.5K, the 1000 volt range, we'll put 500 volts in. There we go. Minus 500, plus 500. Perfect. So let's turn the power off. So that's the finished result. I think I'm very pleased with that, considering it wasn't working when we got it. It's working nicely now. It's got that lovely Nixie tube look to it that everyone likes. Well, I like anyway. It seems to be working perfectly well. Just get it boxed up. I'm going to get some more feet put on it, because apparently it had a tilting bail on the front initially, and that's missing. So I'm going to put a new tilting bail on, and we'll get the cover back on and clean it up, and don't know, put it in the loft, I suppose. Well, I got the top back on it again. It's cleaned up quite nicely actually. Doesn't look like it's had an awful lot of use actually. There's probably been a meter that's sat on a shelf maybe in someone's test room, and has not had a lot of use, occasionally been used. Presently we're sourcing from the Fluke source calibrator. We're actually sourcing a 750 millivolt signal. You can see it's spot on and rock steady. It's calibrated up nicely with that adjustment of that reference voltage. The actual silk screen on the meter says adjust to 12 volts, which I did initially when I first got the meter, but then I couldn't get anything in calibration, certainly in the lower ranges. I was on the end of the pot travel and I couldn't get it to the reading I needed. If I altered the reference voltage, then I could. So basically that's what I've done. I've shifted the reference voltage. As long as the reference voltage stays stable, I can't see it being a problem. So I've adjusted that. We've got our low range in. We'll just demonstrate this with a 0.1 volt input, and you can see it's pretty accurate. It's pretty good. So I'm very pleased with it. Nice old sort of vintage voltmeter in good condition, Nixie tube. So yeah, thanks for watching. As I say, the bike videos will be coming up soon, but in the meantime there'll probably be a few more electronic videos. Thanks for watching.